Hi everyone, today an introduction to LeChatelier's principle. This is a style of question that's non-calculating. That's a nice change for us. It has potentially the possibility to be confusing with icebox questions, but the first thing is icebox is math, LeChatelier, no calculating. Icebox is about doing some math to arrive at a description of what the equilibrium is like. There was an initial setup that moved to equilibrium. LeChatelier is a little bit different. It's a question about a system that was once at equilibrium, and then that equilibrium was disrupted somehow by the addition or removal of a chemical, a change in temperature, a change in pressure or volume. And ultimately, what the question is asking for is, how was the equilibrium reestablished? So icebox questions have an initial setup that moves toward equilibrium, whereas LeChatelier was already at equilibrium, the equilibrium was disrupted, and we returned to equilibrium. There's really only three possible answers: a shift left, a shift toward the reactants, a shift right toward the products, or no shift. So LeChatelier's principle is ultimately a question about how is equilibrium reestablished. It's non-calculating, and there's only three answers: left, right, or no shift. The first situation involves a manipulation in concentration, which is the addition or removal of a chemical. Here's the three possibilities. If we add a reactant or remove a product, we're going to have a shift to the right. Add a product or remove a reactant, it's going to result in a shift left. And if we add a catalyst, there is no shift. For temperature, it makes a difference if we have an endothermic or an exothermic reaction. Okay? If we increase the temperature, we heat the equilibrium system. If the reaction was exothermic, we're going to have a shift left. And besides that, the equilibrium constant, it's going to decrease. So it turns out that the constant is not constant. If, however, we had an endothermic reaction and we heat it, we'll get a shift to the right, a shift towards the products, and the equilibrium constant will increase. If we're cooling it or decreasing the temperature, it's the exact opposite. If it was an exothermic reaction, the shift is to the right, towards the products, and the equilibrium constant will increase. If it was an endothermic reaction and we cool it, we'll have a shift towards the reactants, a shift left. The equilibrium constant will decrease. And the third way we can mess with these systems is by changing the pressure or the volume. The first one is increasing the volume or decreasing the pressure. We're going to encounter either of those. Here, it's not specific. It really depends on the reaction itself. We say that the shift, equilibrium, will be reestablished by a shift toward the side with the greater amount of gas molecules. It's really important to emphasize that that's only about gas molecules. If there's some solids or liquids, we're not going to pay attention to them when we make that evaluation. We're going to be counting the moles. The contrast is also true. If we decrease the volume, increase the pressure, the result will be a shift to the side with fewer gas molecules, with the smaller number of gas molecules. So, LeChatelier is a non-calculating style of question. It describes a situation where we were already at equilibrium, then the equilibrium was disrupted and reestablished. Our answers are basically trying to say, how is the equilibrium reestablished? We have three options: shift left, shift right, or no shift. The concentration, we can add or remove a reactant or a product. We have to pay attention to that one. Notice that with concentration, there is no change to the equilibrium constant. It's only shift left or shift right. With temperature, it made a difference. Whether we had an exothermic or an endothermic reaction, there was a shift left or shift right, depending on the scenario, and also a change to the equilibrium constant. We're not going to be responsible for putting a number on that one. However, being able to say if the constant was increasing or decreasing is an important thing for us to reflect on. Manipulating the pressure or the volume, again, it's quite specific. We have to pay attention to the number of gas molecules, which means we're going to end up counting the moles. And we're going to have a shift to one side or the other depending on what. But once more, here, like with the concentration changes, if we manipulate the volume or the pressure, the equilibrium constant does not change. The equilibrium constant is only going to change if we are experiencing changes in temperature. And I hope that helps.